This is Coach Ray, and I'm going to walk you through the L-5 standard on your linear test. You can use this video to help yourself make test corrections from what you did on the test. Those test corrections can then be turned in and you get an L-5 assignment, and if you complete that L-5 assignment, you will be able to retake this standard and replace the grade that you got the first time. So, follow along with exactly how I did these problems, see how it's different from what you did, and turn that into test corrections which are very clear and explain to me exactly what you did wrong the first time, and we'll move forward from there. So we will start with problem number 1 on L5, and it says write the equation of the following piecewise. And first step to writing the equation of a piecewise is to just start by building the piecewise. So I'm going to say f of x equals, and I'm going to put a brace here big enough to fit 3 equations, because I look down here and I see that we have 3 pieces to this piecewise function. Okay, now, next step, I just need to write the equation of each one of these lines. In order to write the equation of a line, I need 2 things. I need to know the slope, and I need to know the y-intercept. So I'm going to start with the one on the left, and I'm going to start by finding the slope. In order to find the slope, I need 2 points. I see this point right here, so that's a great one to use. And I just need to find another point that is exactly on the corner of the coordinate grid. And I see this one right here. So I've got my 2 points, and now I'm just gonna figure out what is the rise, what is the run between those 2 points. So to get from this point to this point, I'm going to rise down 1 spot. So that's -1. And I'm gonna run to the right 2 spots, and to the right means positive, so that's gonna be +2. So my slope here is rise over run is going to be -1/2 x. Okay, now I just need to figure out what the y-intercept is to put behind it. And the most common mistake on this problem was people thinking that the y-intercept here was 2. It is not crossing the y-axis at 2, it's hitting the boundary at 2. So what we need to do is figure out, if this line were extended out, where it's actually hitting the y-axis over here. So I'm just going to follow this pattern. I'm going to go down 1 over 2 to here. I'm going to go down 1 over 2 to here. And I see that if this line were extended out, it would cross here at the origin at 0. So the equation of this line would be f of x equals -1/2 x plus 0. But I don't need to write plus 0, so I'm not going to. Okay, writing the equation of the second line. I need 2 points again, because I need 2 points to find the slope. After I find the slope, I'll find the y-intercept, and then I'm good. So I've got this point, I'll use this one. There's other ones I could use, but I like ones that I can see right there. Next closest point I see is here. So I'm gonna use these 2 points to find the slope. To get from here to here, I am rising down 3, that's -3. And I'm running to the right 2, so that is +2. Okay, so my slope for this line is gonna be rise over run, -3 over 2, x. Okay, now I don't need to extend my line out at all to figure out what the y-intercept is, because I can see right here that my line crosses the y-axis at -2. So I just have -3 over 2x minus 2. So the equation of this line is y equals -3 over 2x minus 2. Okay, need to write the equation of this third line. I need 2 points again to find the slope. I'm going to use the one they gave me here. And I see one real close right here, so I'll use that one. This looks like my slope is just going up 1 over 1, up 1 over 1. Okay, up is positive, right is positive, so up 1 over 1 is just 1 over 1, which is 1. So my slope here is going to be 1x, which I can just write as x. I don't need the 1. Okay, I need my y-intercept for this line though. So I can't see it at the moment. I need to follow the pattern over and see where it hits. So if I'm going up 1 over 1 here, I'm going to go down 1, left 1, down 1, left 1 to keep that pattern going. And it would hit right here at -2. So the y-intercept of this line would be -2. So the equation would be f of x equals x minus 2. Okay, there's the equations to my 3 lines. Now I just need to put the boundaries in. Okay, so I'm going to put commas there to separate my equations from my boundaries. And my boundaries just are describing where each line is getting graphed. So this line on the left, if I were to describe in English, is getting graphed to the left of here, of -4. Okay, so since we're talking about left and right, that's x. And our boundaries are always in x, because we break the graph up left and right. And if I'm saying to the left of -4, then I'm saying, okay, numbers that are smaller than -4, like -5, -6, -7. So that means x is less than -4. That means to the left of -4. Okay, last thing I need to do here is I need to look at this point. This point is filled in and colored in. So what that means is I need to have less than or equal to right here, because when it's colored in like that, it's going to be the equals to. Okay, when it's open, it does not have the equal to underneath. Okay, I'm going to skip the boundary of the middle one. I'll do that one last. I'm going to come over here to the one on the right, because I think that one's a little bit easier. And I'm now going to say that this, just trying to describe where this line is being graphed, it's being graphed to the right of here, so it's being graphed to the right of 2. So I'm going to use x, and to say to the right of 2, that's numbers that are bigger than 2, 3, 4, 5, 6, so that means x is greater than 2. Okay, so next I'm going to look at that dot. It's open. That means it does not get the equal to underneath, so I'm just going to leave it as x is greater than 2 because that's an open dot. All right, now the boundaries for the middle one. There's 2 of them here. So I need to say 2 things. I need to say that this line is graphed to the left of 2, and it's graphed to the right of -4. So there's kind of 2 pieces to that. In English, we would just say it's graphed in between -4 and +2. So what I'm going to do is I'm going to leave some space here. I'm going to put my x kind of in the middle here. And I'm going to start by saying that my line is being graphed to the left of 2. Okay, to the left of 2 is numbers that are smaller than 2, like 1, 0, and the negatives. So that would clearly be x is less than 2. Okay, so now over here, I need to say that it's being graphed also to the right of 4, or -4. So I'm going to put my -4 in here. And what you have to understand is on this backside, you're reading backwards. So it's going to be x is blank then -4. Okay, so if I'm to the right of -4, that's numbers that are bigger than -4, like -3, -2, -1, 0, 1. Those numbers are bigger than -4. So reading backwards, this needs to say x is greater than -4. Okay, last part, I just need to look at my dots. I see the one on the -4 on the left here is open. So I'm going to leave that as is. I'm not going to put the line underneath. I see that this one here is filled in. So I need this to say less than or equal to. So I'm going to include that line underneath. And that is the final correct answer for number 1. Like I said earlier, I think the biggest mistake on this problem were the y-intercepts. People weren't following these lines over to see where it crossed the y-axis. A lot of people had +1/2 x as their slope here and +3/2 x as their slope here. So you really just have to understand that when you're going from one point to the other, you're going down and then over. And again, here we went down and then over. Okay, in this case, we went up and over, so that was positive. So you really have to keep those slopes signs correct. All right, let's move to number 2. Okay, it says graph the following function. So we've got one boundary here. There's 2 pieces to this. So I'm going to have one boundary and I'm going to have a line on each side. I look at my boundaries back here. I see that my boundary's at 3. So I use a highlighter to mark that boundary. Okay, so I see where my boundary is going to be. And now what I'm going to do is I'm just going to graph both of these lines, y equals x minus 1 and y equals -2x plus 4. And even though I know there's a boundary, I like to just start by graphing both lines all the way. Then I'll just erase the lines where they don't belong, basically. So I'm going to start with the one on top. This top line has a y-intercept of -1. And really, we're just doing the opposite of what we did in the other problem. So my y-intercept is at -1. So I'm going to put that point, and I'm looking at my slope. My slope is 1x, okay? And if I turn it into a fraction, it's going to be 1/1. So what that means is my rise is +1, so that means up, and my run is +1, so that means to the right. So from here, I'm going to go up 1, right 1. There's a point. Up 1, right 1. There's a point. And I'm going to keep this pattern going. Okay, and I can also make it go the other way. If I was going up 1, right 1, I can go down 1, left 1. And I can just keep this pattern going. All right, so there is the top line, x minus 1, graphed all the way across. Now time to graph the bottom one. I'll start with the y-intercept is at +4. Okay, and I'm going to come over here and look at the slope, turn it into a fraction. So I've got -2/1. Slope is always rise over run, so my -2 means down 2. My run means, since it's positive, means to the right 1. So from this point at 4, I'm going to go down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. Keep that pattern going. And I like to make it go the other way, so instead of going down 2, right 1, I'm going to go up 2, left 1, keep it in line, up 2, left 1. All right, so now I've got both of these equations graphed all the way across the graph, which I know is not right, but I'm going to fix it here in a second. But I just think this is an easy way of looking at this problem. Now what I need to do is just by looking at these boundaries, figure out which graph is graphed on the left, which graph is graphed on the right, and then just erase the ones that are in the wrong spot. So I'll start with this one up top. The x minus 1 was this line that I graphed here. And this boundary says that x is less than 3. So numbers that are less than 3 are like 2, 1, 0, all these negatives. So what that's saying is left of this boundary. So I'm going to graph this one only to the left of this boundary. So we always want to use a straight edge. And there's my wonderful ID. There's my straight edge. Okay. And I'm also going to erase these points that are on the right side because I know that those are in the wrong spot. Okay, so my other one's probably graphed on the right, but let me look back up here anyway. It says x is greater than or equal to 3. So the numbers that are greater than or equal to 3 are 4, 5, 6. That means to the right of 3. So I'm going to use my straight edge again. Okay, and I'm going to graph that line there. And I'm going to erase these points that were on the left side that shouldn't be there. All right, so I've got my two lines graphed. The last thing I need is I just need to know, are my dots filled in or open? So I'm going to come back here to my top equation, which was this one, and I see that it says x is less than 3, and it does not have the equal sign underneath. Since it does not have the equal sign underneath, I'm going to make this a very clear open circle. Okay, my bottom one, this line right here, does have the line underneath. The x is greater than or equal to, which means that point belongs right here. So I'm going to put a very exaggerated point with it colored in. And that is exactly what the graph should look like for problem number 2. All right, moving on to the last one, problem number 3. Okay, this says evaluate the following function. So what I need to do is I need to find what f of -2 equals, what f of -3 equals, f of 4 equals, f of -5 equals, and f of 5 equals. So what I need to do is, this is really asking the question, like, where is this function when x is -2? And the key there is x. So when x is -2. So what I need to do is plug this -2 in for x over here somewhere. And I just need to figure out which equation do I plug this -2 into to figure out what f of -2 equals. So what I do is I look at my boundaries. And I see where does -2 fit into one of these boundaries. So I'll start up here. If I put -2 in for x right here, it would say -2 is less than -2. And that is not a true statement. So I'm not using this top equation. If I put a -2 in here, I've got to check two things. I've got to check, is -2 less than or equal to 4? Yes, I'm good. And now I got to read this one backwards. Is -2 greater than or equal to -2? Yes, because that equal to. So this middle equation is the one that I'm going to plug into. So I'm going to come over here to the side on my scratch paper, and I'm going to do -3/4 times -2, and then I've got +1. Okay, so I'm going to put my -2 over 1. I'm going to multiply straight across the top, straight across the bottom. So -3 times -2 is +6. 4 times 1 is 4. And now I've got to add 6/4 to 1. Okay, in order to add fractions, I'm going to turn that into 1 over 1. And I need my denominators to be the same. So I can easily turn this denominator into a 4 if I multiply it by 4. But if I multiply the bottom by 4, I also have to multiply the top by 4. So what I'm going to do now is 6/4 plus, this is going to turn into 4/4. Okay, to add fractions, we just add across the top. So this equals 10 over 4. Denominator stays the same. And this fraction can be reduced. And if you can reduce a fraction, you must reduce a fraction. It's not an option. So I see that a 2 can go into both. So if I take 10 divided by 2, I would get 5. And 4 divided by 2, I would get 2. So that is how I find f of negative 2. So I'm going to bring that over here. F of negative 2 should be 5 over 2. Okay, next one, negative 3. F of negative 3. So I just need to look here and figure out which of these boundaries does x being negative 3 fit into. So I'll start at the top. Is negative 3 less than negative 2? Yes. Okay, it's not in between negative 2 and 4, and it's certainly not greater than 4. So I'm plugging it into this top equation. So here was the key here that a lot of people messed up. This is negative x, and I'm saying that x is negative 3. So I'm going to plug in negative and then negative 3. So it would look like this. Negative, negative 3, and then I do my minus 6. So obviously negative negative becomes positive. So positive 3 minus 6 is going to equal negative 3 right here. A lot of people just put negative 3, but they didn't have that extra negative there. All right, I'm going to move on to f of 4. Okay, I'm going to look down here and say, okay, is 4 greater than 4? No, not true because it doesn't have the equal sign, so I'm not using the bottom one. If I put it in the middle, it's got to meet both requirements. So if I read this part backwards, is 4 greater than or equal to negative 2? Yes, check. Is 4 less than or equal to 4? Yes, because of that equal to sign. So this one, I need to do negative 3/4 times 4 plus 1. So I'm going to put my 4 over 1. I'm going to multiply straight across the top and bottom. Negative 3 times 4 is negative 12. 4 times 1 is 4 plus 1. And here I need to just recognize that negative 12 over 4 is just negative 3. So negative 3 plus 1 equals negative 2. So the answer to f of 4 is negative 2. Okay, f of negative 5. Same thing as before. I just need to go through and see which boundary this fits in if x were negative 5. If I put negative 5 right here, is negative 5 less than negative 2? Yes. So I'm going to use the top equation. Again, I've got negative, and then x is going to be negative 5. So this is going to be negative, negative 5. And then I've got minus 6. So negative negative will turn to positive. So positive 5 minus 6 is going to equal negative 1. So f of negative 5 should be negative 1. Okay, last one, f of 5. When x is 5, I'm looking through these. I notice this bottom one. If I made 5 right here for x, 5 is greater than 4 is a true statement. So I'm going to use this bottom equation. So that means I'm going to plug in here, and I'm going to do 2 times 5 minus 7. 2 times 5 is 10. 10 minus 7 is 3. So f of 5 equals 3. Okay, that is all of the L-5 standard. You should take this and use this to make your test corrections. Don't forget, I want 2 things from your test corrections. I want you to explain to me in words, detailed and specific, what did you do wrong on the problem. I also want you to show me what's correct. So really what you're going to do is reproduce this on your paper and show me that you know how to do these problems correctly. So 2 things again, you're explaining to me what you did wrong, and you're showing me what's right. And you only have to do that for the problems that you got wrong. Okay, so get those test corrections done this weekend if you can. Get them to me as soon as possible. I'll get you an assignment on L5 so that you can practice this. And as soon as you are done that assignment, you can turn that in and retake L5, and I will change your grade on L5 for however you do the second time. Okay, hope this was helpful. See you guys soon. Talk to you later.